Okay, significant figures. Numbers can be rounded to decimal places. Now we know that you know how to round to decimal places. And in year 10, or I think, year 10 or year 9, you would have learned how to round it to significant figures. An example of rounding to significant figures is as follows. They might say that at the soccer match, at the Sydney Derby, there was a crowd of 20,000 people. It's not exactly 20,000. Well, let's say it was 21,000. It wouldn't have been exactly 21,000. That 21,000 is probably rounded to the nearest thousand. All right? So there would be an error in that measurement. Like population of Australia, anyone know what it is at the moment, roughly? So, another example of significant figures. The population in Australia as of the 30th of June 2016 is 24,378,529. No one goes around saying Australia has 24,378,529. People might say Australia's population is about 24 million. Do you get it? They're not going to say even probably 24.5 million. They often just give it to the nearest million. Now 24 million is 24,000,000. So that's actually rounded to the 24. It's called two significant figures. But we'd have to put the zeros in so that I don't say Australia's population is 24. It's roughly 24 with 6 zeros, 24 million. That's what we're doing today, stuff like that. There are rules for rounding to significant figures. The first rule is this. The first significant figure in a number is the first non-zero digit. So for example, what's the first significant figure in this number? 3. See these girls? 0 is not significant. What's the first significant figure in this number? So it's the first non-zero digit. So these are some rules. You might want to highlight that first row. The first significant figure in a number is the first non-zero digit. So this is the first non-zero digit, the 3, and then this other one, the first non-zero digit is a 2. Bit of a tricky one next. Zeros at the end of a whole number or at the beginning of a decimal are not significant. They are just there to hold place values. So they are necessary placeholders. So for example, how many significant figures? So all these zeros at the end, like my 24 million for Australia. So if I go, I'm just going to write it here, population 24, 3, anyone remember the number? I'll just go 378,592, roughly. When I say Australia is roughly 24 million, I've rounded it just to 2 significant figures. Because 24, 378,592 is closer to 24 million. So I say 24 million. I don't round that and say there's 24 people living in Australia. I need to put the zeros on the end, so it still is roughly 24 million. Okay, so girls, how many, highlight the non-significant zeros. Which ones are not significant? All these end ones. They're only there, so those last 4 zeros there aren't significant, meaning it's not exactly 1,340,000. It could be, that number could be 1,339,990, but it's just closer to 1,340,000. I know I've probably just confused you. But see, zeros on the end are not significant. What about, do you remember, what's the first significant number here? So these zeros at the front are not significant. So again, zeros at the end of a whole number or at the beginning of a decimal are not significant. They are necessary placeholders. Look, most of the time they're not significant on the end. There are cases where they are, but you'll know when that happens. Now, next, zeros between non-zero digits or zeros at the end of a decimal. So zeros at the beginning of a decimal, they're not significant. They're just there to say there's no tenths, there's no hundredths, but we start on the thousandths, right? But girls, zeros between non-zero digits, in other words, this 0 in here is significant. It's a number. but the zeros on the end aren't, okay? So highlight the significant zeros. This one, 0 is significant. So that is significant, but the zeros on the end aren't significant. I know this is. What about these zeros at the beginning? Are they significant? So I'm going to outline and I'm going to go not significant. These two are not. But which 0 is significant? That's significant, and zeros actually at the end of a decimal are significant. So the not significant are the zeros at the front here, but these two on the ends are. See, I'll tell you what that's like. I'll show you. Let's say you weigh yourself and you're 64.4 kilos, right? But then let's say someone else decides to write 64.400. See, the scale at home only gives you 64.4. You know, it only gives you one decimal place on the digital scales. If you put 64.400, it's telling me that you know it this accurately, and you don't. You don't know about the second decimal place and the third decimal place. So if you're recording weight on scales, you only record what you can see. You don't go adding extra zeros. These extra zeros mean that you know it, that it's exactly 0.400 instead of being maybe 0.412 or something. All right, so don't add extra zeros on the end of a decimal unless you've measured it. All right, that's what that's saying. So you would write this, not that, on a scale. All right, you don't write it like 64.400. Now, these questions. To how many significant figures has each of the following been written? How many? Count the numbers. 1, 2, 3. Good. Now, are zeros at the end of a decimal significant? So 1, 2, 3, 4. Even though that could be someone's error. This one. No. Zeros at the end of a decimal are significant. That's 5. What about these zeros at the front? Significant or not? No. So how many? Good. What about here? Only 2. So zeros at the end of a decimal are significant, but zeros at the end of whole numbers aren't. This is like us saying there were 7,000, roughly 7,600 people watching the game on the weekend. It's not exactly how many people. So that's only 2. I know that's a bit tricky. So girls, you know with decimals, unless you've really recorded it that accurately, you're not supposed to put the zeros on the end. But if you go writing zeros on the end of a decimal, you're telling them, I know it's this accurate to this decimal place. My instrument can measure such small quantities. All right? So, I don't think there's anything that you have that can measure to that anyway with all the extra zeros on the end. You won't be doing that. All right, next. To round a number to a required number of significant figures, this is what we do. Find the first non-zero digit from left to right. From this first significant figure, count the number of significant digits, including zeros. Stop at the required number of significant digits. Round the last digit. All right, it's all a load of, a lot of rules. The best way to do it is with examples. And replace any non-significant digit to the left of a decimal point with a 0. Okay. Write the following to 3 significant figures. Now these ones are easy. I just want 3 numbers. What's it going to be? 47.7. That's following this. Locate the first digit is 4. Then we'll round, I want 47 point something. I only want 3 numbers, right? This one, round to 3 significant figures. 91 point, I need one more number. Good. You know those squiggly equal signs? That means approximately equal to. All right, this one, 273,200. Because I've got 4 numbers. I don't want this 2. So is that closer to 273,000? Do I keep this as a 3 or do I make it a 4? I keep it as a 3 because there's a 2 after it. What do I do now? So you're saying 273,200 is approximately equal to 273,000. It's like the population thing of Australia, the number of people that go to the football game, all right? I only want 3 figures. Because this is a whole number and it's a big number, you fill in the rest with zeros. What happens if, can I just do one more? Can we round 285,592 to 3 significant figures? 285,592. Wait, Heidi, go. 280. So these, I just want 3 figures. 1, 2, decide, and now what do I do? 1,000. So you would never write 285,592 is approximately equal to 286. No, that says the non-significant figure, oh yeah. Oh, to the left of a decimal point. In other words, in a whole number. In the whole number bit. There you go. Replace any non-significant figure to the left of a decimal point. Where's the left of a decimal point? It's the whole number part. The right of a decimal point is the decimal part. In other words, if you've got whole numbers, replace any non-significant digit in a whole number, really, with a 0 after the... Yeah, we're doing it right. We're just interpreting the rule. Okay? But do you get this idea? I want 280 something. All right. Let's look at the next ones. Are we good? Round each of these to 1 significant figure. Now, these zeros at the beginning are not significant. 0.00. What do I do with this one? Does it stay as an 8? I'm only allowed 1 number, apart from all the zeros at the front. 8 or 9? Because the number after it is a 2. What about this to 1 significant figure? 21.45. I'm only allowed... Well, this 2, I've got to decide on this 2. Does it stay as a 2? What do I replace the rest with? 0. I'm just going to leave it as 20. Do you get it? 21.45, isn't it? All right, it's just about 21, isn't it? It's closer to 21, but you're not allowed to. If I put 21, that's 2 significant figures. Zeros at the end are not significant. I'm saying to you, you know what this question's asking you? Round 21.45 to the nearest 10. Very good. Yes. To 1 significant figure, I just want it to the nearest 10. Is that closer to 10, 20, or 30? See, the 2 significant, the 0 is not. If I write my answer as 21, that's 2 numbers I've given you. Do you get it? Girls, if you can do this, it's the same sort of thing. I know it's tricky for you because it's such a small number. But you're only allowed a number and the rest have to be zeros. So that's approximately 20. All right, what about, this is a tricky one. So doesn't this get rounded up? 0.998, what does that round to? 1. That's it, not 1.0. Because if you put a point and a 0, zeros at the end of a decimal are significant. So it's just the number 1. Round these to 2 significant figures. All right, 2, I'm allowed another number. What's it going to be? 5 or 6? So you've got to decide on this. What do I do now? 253.91 is approximately equal to 25 or 250? Girls, do you get that? 253.91, I'm allowed 2 numbers. I can't just write my answer as 25. I have to write it's approximately 250. I've still got the units column to do. Remember, if there are any non-significant digits to the left of a decimal point, and that 3 is to the left of a decimal point, I'll replace it with 0. So I'm saying 253.91 is approximately equal to 250. Do you get it? All right, this one to 2 significant figures, 0.002 Good. 2, and decide on the 7. Does it stay as 7? Yes, because the 1 after it is less than 5. 568,810. 5, here's my second figure. What's it going to be? 7. What do you replace the rest with? It's all a whole number, 0, 0, 0, 0. In other words, 5, so you have to decide, I'm only allowed 2 numbers. See, if it's a decimal, you don't add anything else at the end. But if it's a whole number, you have to put zeros. I can't say 568,810. Oh yeah, that's approximately equal to 57. That's ridiculous. It's approximately 570,000. If you were saying, yeah, that's roughly this amount. Significant figures in measurement. See, here's tape A and here's tape B. Which tape do you think you could read more accurately? Tape A or B? Good. So on tape B, you're allowed to give me 27 point something. You could read it properly, couldn't you? But you know, on tape A, you're only allowed to say 27, 28, 29. You're not allowed to give me decimal places. All right? You're not allowed to. So if even I was exactly, you know, a little bit over 27 and a half here, I say it's 28. Whereas this one, you are allowed to give me 0.1, 0.2. On the first tape, you're not allowed to say 27 point something, all right? You're not allowed to, because they're not marked. So that's what it's saying. Sections of two tape measures are shown. Tape A, the units are 1 centimetre apart, while tape B, the measurement units, are 0.1 centimetre apart or 1 millimetre apart. Write the measurements shown on tape A and tape B. So tape A, what's that measurement? What is it? 28 centimetres. How many significant figures? 2 sig figs. Tape B, let's say it was just over 28. It was the next line across. What would it be if it was the next little dash? 28.1. What was if it was the one below that? 27.9. Just because it's 28, why don't I put 28.0? Because I do know it's exactly 28.0. Do you see? I'll show you. All right, we're zooming in. Right, watch. Girls, they're both, this measurement underneath it, the one before would be 27.9. This is 28.0, 28.1, 28.2, etc. That tape measure, you're allowed to say 28.0. Do you get that? How many figures? Zeros after the end of a decimal, at the end of a decimal, are significant. How many figures? This one's 3. So, because, watch what I'm doing up here. Before the 28, I would have 27.9, 28, 28.1. Why don't I say 28.0? Because I know it is exactly 28.0. The number before the 28 is 27.9. So I can't say that's 3 significant figures, that is. And why isn't the one in the middle significant? It is in this case. In this case, I can read it that accurately. It is, at the end of a decimal, they are significant. So if you write 28.0, it means that you can tell me it's exactly, yes, but it is exactly 28.0. Yeah. You can't read 28.90 on this one. Yes, if we did write that, you're saying that you know it that accurately, and we'd have to zoom this in, and it means you've got another 10 divisions between there and there. But do you understand why it works here? Because you can see 27.9. Yes, the other one would be 4, but you don't write it. Yeah, but can you see why this one is 3? Which one is more accurate, tape A or tape B? Tape B, because it's 2, 3 significant figures. I just write sig figs, all right? Do you get it? Whereas, you know, so that's more accurate. Now, Tong, or Tuong, recorded a measurement of 57.4 using tape A. Girls, you're not allowed to do that on tape A. What should he have written? You're only allowed to use whole numbers on tape A. Good. What should he have written? Yeah, but what? He's not allowed to write 57.4 on tape A? Very good. 57 centimetres. Now, got it? Tape A, you're only allowed to give me whole numbers, but tape B, you're allowed to give me a decimal point and another number. Does that make sense? Yeah. So tape B, Juliet recorded a measurement of 19 centimetres, meaning she was spot on 19. How should she write it on tape B? Fantastic. She should have written 19.0. Why? Because, for example, you can show it. Do you know what I mean? You can show it like this. She could tell it's not 18.9. She can tell it's not 19.1. She knows it's exactly sitting on that 19.0. It's because tape B can be read to 3 significant figures. Do you get it? Tape B, you can read it much more accurately than tape A. All right, this last thing is very important. The number of significant figures in a given measurement indicates the degree of accuracy. Now, you can just see now how 28 and 28.0 are different. Did you see from that example? If you write 28.0, it means that you can read it exactly, and that the measuring tape has got, you know, the millimetres in it basically, but this first one, tape A, doesn't. So 28.0 indicates a very accurate measurement. For example, a measurement is given as the following: 1.3 metres. That's 2 significant figures, 1.3. Now, you tell me what the next number up here would be and the next number down there. This is relating, not quite, 1.2, 1.4, if you were counting. If you decided 1.3, wouldn't the one before it be 1.2? The next one would be 1.4. This is like what we did last lesson. What does the real length lie between if I'm saying 1.3? Oh, it could be, but it could be less than that too. Good. But, do you get it? You could, so yes, you could be 1.29, you could be 1.28, you could be 1.27, 1.26, or 1.25. We know it doesn't include the 1.35, all right? We know that. All right, the next one, watch. 1.30. Yeah, but a bit different. See how that's 30 after the decimal point? What number comes before 30? Good. What number comes after 30? Now, I know I'm not supposed to, as a maths teacher, say 1.30. That's so wrong. But it makes it easier for you to know the number before it. Do you see? All right. So you tell me, we know where you're going to decide that it's 1.30. It's from there to there. What are those numbers? 1.29. Because really, if you want to work that out, you go 290, 300, 310. And 1.305. So this is for, I'm going to call this one A. That's the diagram for A. This one B. That's the diagram for B. Get what I'm doing? This one C. Now, if you write 1.300, it means you know it that accurately. Now, I'm going to draw that one. I hope I've got room. So this is number C. 1.300. What's the number before and after 300? What number is 299? 1.3 what? Do you get that? 300, 301, 299. There's the halfway mark. There's the halfway mark. What does the real measurement, the real length lie between? 1.2995 and 1.3005. I know that one's a bit tricky. All right. Now, if you're not sure how to do it, this is like what we did last lesson. Your smallest unit. Do you know what your smallest... All right, we're going to go back and revise what we did last lesson. You ready? Can I move? Tell me what the smallest unit here is.
0.1.
Very good. What's my absolute error? Half of 0.01, 0.05. What's my smallest unit?
0.01.
Because it's the second decimal place. See how it's that 0 changes to a 1? The smallest unit is 0.01 to the second decimal place. So the absolute error is half of that, which is 0.005. And what we've been doing is we take that measurement of 1.30 and we subtract 0.005 to get that, and we add 0.005 to get that. And the smallest unit on this last one is what? So 1, 2, 3. It's on the third one. It's 3 decimal places. So the absolute error is half of that, and if you do half of that on your calc, you get 0.0005. Okay?